This might be the world's smallest 3D printed robot arm. Today I'll show you how this arm cost me less than $50 to build and how it can possibly be so small. Today I'm going to attempt to build the world's tiniest robot arm. So what I'm thinking here is that in order to make this arm truly tiny, we need to eliminate all of the motors from the joints of the arm. Now luckily the idea of using systems of parallel beams and levers to move some of the motors lower to the base of the arm has been around for a while. But what I haven't seen done is a way to move the motor in the gripper that's all the way on the end of the arm down to the base of the robot. The reason we don't want a motor out on the end like this is because it limits how small the gripper and arm can be and creates extra weight for the other motors to have to lift. So I'm going to have to figure out a way to move that down. I'm also going to have to move this motor out to the side. First, let's create a rough sketch of what this arm might look like, and then we can figure out how to fit all the motors on later. Okay, here's what I've got. I made this super rough cutout out of staples and paper, and this is essentially how the robot will move. And now we design it. Alright, I've made a little thing in Fusion 360, so now you might actually be able to tell what's happening. Maybe. So basically there are just a bunch of levers working together. Oh gosh. A bunch of levers to move some things and keep the rest parallel. You'll be able to see this better later. Okay, I think we're ready for a prototype. Let's get it printed. The entire arm took less than 2 hours to print. This is a robot. It's hard to visualize how small this is until you actually see it. Let's attach the motors. Alright, this seems like a good point to show you all the hardware. I'll be using 4 microservos, an Arduino Nano, a lot of really tiny screws, and then obviously the 3D printed parts. All this brings the total cost to just $40. Okay, servos are on, and I actually printed another prototype here with updated tolerances, servo covers, and a TPU gripper. So it's all wired up, and there's a wiring diagram in the description because right now this is kind of a disaster. Eventually I'm going to print a nice box for this and solder all the wires to the board, but right now it's kind of a mess. I'll also improve the wire management on the final design, but this is mostly just here to test the code. So let's try it. Okay, code is being uploaded. It's done. Should grab this from me. Spin it up. Okay. I think on the final one I'll add lubricant to all these joints to hopefully reduce some of the jittering, but it's actually smoother than I thought it would be for these cheap servos. Okay, just a few small changes to make in the design, and then I think we're ready to print the final arm along with the cover for the Arduino. Alright, here it is. Now we just need to attach the Arduino cover. There we go. Now obviously this arm isn't practical at all, but it shows just how small you can make something like this by removing the need for motors fixed to the joints. It was super fun to make, and I'm kind of surprised how well the pieces went together. Let me know if you have any questions in the comments, subscribe for more, and support my work on Patreon if you'd like to. Thanks.